So when we're talking about the asteroids, we talked about discovering them and measuring them and so forth, but we want to really find out more about them. What are they like? What are asteroids? When asteroids were discovered, they only knew of a couple of things in the solar system. They knew about the gas giant planets. They were starting to realize they weren't solid, and they knew about the rocky inner planets. So for a very long time, since asteroids had the same spectrum as the rocky planets, they were simply considered to be basically rocky. Now, some of them have a little more iron in the spectrum than others. Some have a little more carbon in the spectrum than others. But again, they were considered basically big solid rocks. But no one knew for sure because, after all, I mean, they're a long ways away and they're very small. One thing that we can say is they are very small. Sometimes in books I've seen in old books that were written by less professionals, I saw that the asteroids are sometimes speculated to have once been a big planet that blew up or something. But if you add all the asteroids together, they're not very big. Here's, for example, the moon compared in size with some of the biggest, with the 10 biggest asteroids. So the asteroids are not very big. And even if you put them all together, they don't add up to that big of a world. They add up to really not much more than our moon, putting all together. Only recently, as in the last few decades, have asteroids actually been seen up close. And so now we start finally seeing what they're like. Now, prior to that, though, for many, many years, they would have an idea what asteroids were shaped like by looking at occultations or radar imaging. So for an occultation, the way that worked is that different people in different parts of the world be watching. So you'd have the Earth here, and you got stars in the background, and you got the asteroid going by, and so people on one side of the world would see the star, and nothing happened. And then people near them would see like a little gap there, and then the next to them would see a little bit bigger gap. In other words, that's in time. So this is a graph of time versus brightness of that star. And so what they would do was they would look at that and say, well, gosh, that suggests the asteroid is shaped something kind of like that. Okay. And so from putting together these timings, and often there were amateur astronomers that were doing this, they would have a time signal and they'd be keeping track of the asteroid, and they were able to build up over time a rough idea what the asteroid is shaped like. For example, the asteroid Geographus, each dot in that image marked a spot where astronomers recorded the light stopping or starting from a star that was being occulted. Obviously, a few of the dots in the middle suggest, somebody made mistakes, but you get a rough idea because there's a pretty decent agreement here among most people. As some of these asteroids pass close to Earth, Arecibo or Goldstone radio observatories, which have massive radar transmitters in them, can bounce radar off the asteroids. And so we, for example, discovered the asteroid Castelia looks like this, a double-lobed sort of thing. Now, one thing about this double-lobed structure is that the way the radar bounces off, you don't really know if it's really two objects here touching, or if it's two objects that are really, really close together, orbiting around each other, and the radar, as it comes back, doesn't really give you that much detail. So it could be that could be a double asteroid, or it could be that two smaller asteroids, gravity pulled them together until they're touching. Now, this actually is an interesting sort of thing, because when we look at some of these other asteroids, for example, the asteroid Cleopatra, again, this dog bone shape, again, we don't really know in the middle here if that's really touching or not, or is this, what would make a shape like that? There's nothing physically that would make a good shape like that unless two smaller things pull themselves together. Now, that's really fascinating because while we see several asteroids, in fact, a lot of asteroids that look like these double lobe things, we sometimes see on Earth, this is actually a picture of Earth, so craters on Earth, but sometimes on the Moon and Mars and other worlds that have craters, we see double impact structures. So that suggests that maybe a lot of these asteroids really are two things that are close together, and when they run into something, we get these twin craters. The asteroid Vesta is a very large one, and Vesta is potentially almost like a dwarf planet. Ceres is the largest of the asteroids, and so Ceres is huge. It's about 1/3 of the total mass of the asteroid belt, and their Ceres is in comparison to Earth and the Moon. It's about 600 miles across. So Ceres is smaller than Texas. For a while there, because it pulls itself into a spherical shape, it was on the list of planets. But it's hard to call something smaller than Texas a planet. Ceres, seen from Earth, normally it looks like a little dot, but the Hubble telescope can look at Ceres without having to look through the atmosphere, and so it can image. There's bright and dark markings on it, and so that's a very good image from it from a long ways away. From this, we kind of get the idea that it's probably got an inner rocky layer and maybe an icy outer part. Remember, some of the stuff that makes up these rocks that fly around the sun have some water in them. And so this is far enough from the sun that that water be frozen. And so it might, the rocky stuff would sink to the middle, the lighter stuff would float to the outside. And so that would give you kind of a rocky interior and then like an icy mantle. The first asteroid that we actually saw up close was the asteroid Gasper. And Gasper was really seen kind of as a byproduct of another mission. We had a spacecraft that was on its way to Jupiter and was going through the asteroid belt, and they intentionally sent it slightly off on a little bit less than the most ideal orbit to Jupiter in order to pass within close distance to an asteroid, the asteroid Gasper, and that gave us our very first picture of it. So this was quite some time ago, and it was a huge step forward. It's a solid object. We can tell from the craters that are on it, this is a pretty solid object. It's got a weak magnetic field, means it's got iron in it. That was a little bit of a surprise. It's got grooves on it, and the grooves here are believed to be cracks from an impact. Okay. Next one that was visited was the asteroid Ida. There was a spacecraft that was visiting again on the way through the asteroid belt, and the asteroid Ida. And we noticed it has very soft craters right here. Okay, that's suggesting that this is not quite as solid of an object. In fact, it's kind of puffy. Okay, this suggests that some asteroids are maybe, instead of being solid, they're loose conglomerations of stuff being held together. Now that's a huge difficulty, because that means if they're not solid, one of the strategies here for dealing with the asteroids is like running into them. Okay, well, they're not solid, so whatever you run into them is going to bury itself in there. Again, very soft craters here in places, again, not solid. Notice there's something else in the background back there. Okay. That something in the background is very interesting. Okay. A lot of the amateur astronomers, that were using occultations to try to map the size of asteroids. Some of them outside of the path of the asteroid would sometimes say they saw an occultation. Most professionals just said, oh no, they just imagined that. But here we have something here. Now, when I think of asteroid belt, you often kind of think of the Millennium Falcon flying through the asteroids and all the asteroids close together. That's not really the way it is. is so much space between all the asteroids. If you're standing on one of them, the nearest asteroid is so far away, it's probably not going to be even visible to the naked eye. And yet here we have something there. What is that? Well, it turns out that's actually a moon, a tiny asteroid orbiting the big asteroid. So that little thing, Ida, moon, officially is called Dactyl. Now, I will admit that when the discoverers found it, we have Ida is the asteroid, and so they actually proposed the name Ho for the moon, okay, Ida Ho. However, the IU Commission on Names said, no, we're not going to permit a name like that, okay. We're not going to have a frivolous name here. So they came up with the name Dactyl instead. Officially, it's 243 Ida 1, meaning it's the first moon around the big asteroid 243 Ida, and the name of it is Dactyl.